NENOMATICA, where mathematics meets YouTube excellence. Welcome to our math lesson. Today, we'll work through an algebraic expansion and factorization problem together. We'll solve this step by step to help you understand the process clearly. Let's start with our expression. We have a squared times b squared times open parenthesis b minus a close parenthesis plus b squared times c squared times open parenthesis c minus b close parenthesis plus c squared times a squared times open parenthesis a minus c close parenthesis. In our first step, we'll expand each term separately. Let's start with the first term. A squared times b squared times open parenthesis b minus a close parenthesis. When we distribute, we get a squared times b minus a squared times b squared times, which simplifies to a squared times b cubed minus a cubed times b squared. Now, let's expand the second term. B squared times c squared times open parenthesis c minus b close parenthesis. When we distribute, we get b squared times c minus b squared times c squared times b, which simplifies to b squared times c cubed minus b cubed times c squared. Finally, let's expand the third term. C squared times a squared times open parenthesis a minus c close parenthesis. When we distribute, we get c squared times a minus c squared times a squared times c, which simplifies to c squared times a cubed minus c cubed times a squared. Now, let's combine all our expanded terms together. We have a squared b cubed minus a cubed b squared, plus b squared c cubed minus b cubed c squared, plus c squared a cubed minus c cubed a squared. Let's rearrange these terms to find a pattern. We can group them as open parenthesis a squared b cubed minus b cubed c squared close parenthesis, plus open parenthesis b squared c cubed minus a cubed b squared close parenthesis, plus c squared a cubed minus c cubed a squared. We can further factor this expression. We get b cubed times open parenthesis a squared minus c squared close parenthesis minus a squared times b squared times open parenthesis a minus c close parenthesis plus c squared times a squared times open parenthesis a minus c close parenthesis. Now, we can use the difference of squares formula. We know that a squared minus c squared equals open parenthesis a minus c close parenthesis times open parenthesis a plus c close parenthesis. And also, a cubed minus c cubed equals open parenthesis a minus c close parenthesis times open parenthesis a squared plus a c plus c squared close parenthesis. Looking at our expression, we can see that open parenthesis a minus c close parenthesis is a common factor in all terms. So we can factor it out, giving us open parenthesis a minus c close parenthesis times open square bracket b cubed times open parenthesis a plus c close parenthesis minus b squared times open parenthesis a squared plus a c plus c squared close parenthesis plus c squared a squared close square bracket. Now, let's simplify the expression inside the square brackets. When we expand, we get b cubed a plus b cubed c minus b squared a squared minus b squared a c minus b squared c squared plus c squared a squared. Let's group similar terms together. The first thing we'll do is use the distributive property to factor out common terms within each group inside the brackets. We can see that in the first group we can factor out b squared to get b squared times a times b minus c. In the second group, we can factor out b squared times c to get b squared times c times b minus c. And in the third group, we can factor out a squared to get a squared times negative b squared plus c squared. Next, let's use the difference of squares identity to rewrite the last term. We know that b squared minus c squared can be factored as b plus c times b minus c. So our expression becomes a minus c times the open bracket b squared a times b minus c plus b squared c times b minus c minus a squared times b plus c times b minus c close bracket. Now, we notice that b minus c is a common factor in all three terms. So we can factor it out. Our expression becomes a minus c times b minus c times open bracket b squared a plus b squared c minus a squared times b plus c close bracket. Let's distribute and combine like terms inside the innermost brackets. We have b squared a plus b squared c minus a squared b minus a squared c. Notice that we've expanded the a squared times b plus c into a squared b plus a squared c. Now, looking at the image, it seems there was a note indicating a new algorithm or approach. Let's continue following the steps as shown in the input image. Now, we can factor out common terms from each group inside the curly braces. From the first group, we can factor out b times a to get ab times b minus a. From the second group, we can factor out c to get c times b squared minus a squared. Once again, we can apply the difference of squares identity to the term b squared minus a squared. This gives us a minus c times b minus c times the expression a b times b minus a plus c times b plus a times b minus a. Now, we can factor out b minus from both terms inside the curly braces. This gives us a minus c times b minus c times b minus a times ab plus c times b plus a. The result is a minus c times b minus c times b minus a times ab plus cb plus ac. This is our final answer. Welcome to this math video where we'll learn how to solve a complex algebraic factorization problem. We'll go through this step by step to make sure you understand each part of the process. Let's start by looking at the expression we need to factorize. We have a squared times quantity b cubed minus c cubed, plus b squared times quantity c cubed minus a cubed, plus c squared times quantity a cubed minus b cubed. The first step in any factorization problem is to expand the expression using the distributive property. We'll apply the distributive property to each term. For the first term, a squared times b cubed minus c cubed becomes a squared b cubed minus a squared c cubed. For the second term, b squared times c cubed minus a cubed becomes b squared c cubed minus b squared a cubed. And for the third term, c squared times a cubed minus b cubed becomes c squared a cubed minus c squared b cubed. Now, we need to rearrange the terms to make it easier to identify patterns for factoring. We can rearrange the terms by grouping similar components. In this step, we'll regroup the terms to prepare for factoring. In step 3, we'll factor out common terms from each group. Let's factor out the common terms from each group. From the first group, a squared b cubed minus c. Squared b cubed, we can factor out b cubed to get b cubed times quantity a squared minus c squared. But we'll write this as negative b cubed times c squared minus a squared to match our later steps. From the second group, negative a squared c cubed plus c squared a cubed, we can rewrite as negative a squared c squared times c minus a. From the third group, b squared c cubed minus b squared a cubed, we can factor out b squared to get b squared times quantity c cubed minus a cubed. In step 4, we'll apply the difference of cubes formula to factor c cubed minus a cubed. Remember, the difference of cubes formula states that a cubed minus b cubed equals quantity a minus b times quantity a squared plus ab plus b squared. So c cubed minus a cubed becomes quantity c minus a times quantity c squared plus c a plus a squared. Next, we need to also apply the difference of squares formula to the first term. The difference of squares formula states that a squared minus b squared equals quantity a minus b times quantity a plus b. So c squared minus a squared becomes quantity c minus a times quantity c plus a. Now we can rewrite our expression as b squared times quantity c minus a times quantity c squared plus a c plus a squared minus a squared c squared times quantity c minus a minus b cubed times quantity c minus a times quantity c plus a. Now we can see that all terms share a common factor of quantity c minus a. Let's factor out quantity c minus a from all three terms. This gives us quantity c minus a times quantity b squared times quantity c squared plus a c plus a squared minus a squared c squared minus b cubed times quantity c plus a. Let's expand the expressions inside the bracket to continue our factorization. We'll multiply out each term. b squared times c squared is b squared c squared, b squared times ac is b squared ac, and b squared times a squared is b squared a squared. So our expression inside the brackets becomes b squared c squared plus b squared, a c plus b squared a squared minus a squared c squared minus b cubed c minus b cubed a. Now, let's rearrange these terms to identify patterns that will help us factor further. We can rearrange the terms as b squared c squared minus a squared c squared is c squared times quantity b squared minus a squared. b squared ac minus b cubed c is negative b squared c times quantity b minus a. b squared a squared minus b cubed is negative b squared a times quantity b minus a. Now we can see that quantity b minus a is a common factor in the last two terms. Let's factor out quantity b minus a from those terms. This gives us quantity c minus a times quantity b minus a times quantity c squared times quantity b plus a minus b squared c minus b squared a. Let's expand the remaining expressions to identify more patterns. We have c squared b plus c squared a minus b squared c minus b squared a. We can rearrange this as quantity c squared b minus b squared c plus quantity c squared a minus b squared a. Now we can factor each group inside the bracket. From the first group, c squared b minus b squared c, we can factor out bc to get bc times quantity c minus b. From the second group, c squared a minus b squared a, we can factor out a to get a times quantity c squared minus b squared. Now we can apply the difference of squares formula to c squared minus b squared. Recall that c squared minus b squared equals quantity c minus b times quantity c plus b. So our expression becomes quantity c minus a times quantity b minus a times quantity c minus b times quantity bc plus a times quantity c plus b. For the final step, let's expand and simplify the last bracket. We have bc plus ab. So our completely factored expression is quantity c minus a times quantity b minus a times quantity c minus b times quantity cb plus ac plus ab. Today we're going to factor the expression a to the sixth power plus a to the fourth power plus a squared b squared plus b to the fourth power minus b to the sixth power. Let's break this down using algebraic factoring techniques and rules. The first step is to group and organize our terms to make factoring easier. Let's group similar terms together. We can rewrite this as a to the sixth minus b to the sixth plus a to the fourth plus b to the fourth plus a squared b squared. Now let's focus on the first group, a to the sixth minus b to the sixth. We can factor this as a difference of cubes. Remember that a to the sixth minus b to the sixth can be written as a cubed minus b cubed times a cubed plus b cubed. So our expression becomes a cubed minus b cubed times a cubed plus b cubed plus a to the fourth plus b to the fourth plus a squared b squared. Next, let's handle the term a to the fourth plus b to the fourth. We can rewrite this using the formula for the sum of squares. Using the identity that a squared plus b squared equals the quantity a plus b squared minus 2ab, we can write a to the fourth plus b to the fourth as the quantity a squared plus b squared squared minus 2 a squared b squared. This gives us a cubed minus b cubed times a cubed plus b cubed plus the quantity a squared plus b squared squared minus 2 a squared b squared plus a squared b squared. Now we can simplify by combining like terms. The negative 2 a squared b squared and the positive a squared b squared combine to give us negative a squared b squared. So our expression simplifies to a cubed minus b cubed times a cubed plus b cubed plus the quantity a squared plus b squared squared minus a squared b squared. Let's continue factoring by using the formulas for the sum and difference of cubes. We know that a cubed minus b cubed equals a minus b times a squared plus ab plus b squared. Similarly, a cubed plus b cubed equals a plus b times a squared minus ab plus b squared. Applying these formulas, our expression becomes the product of a minus b, a squared plus ab plus b squared, a plus b, and a squared minus ab plus b squared, plus the quantity a squared plus b squared squared minus a squared b squared. Now, let's focus on the remaining terms. We need to factor the expression a squared plus b squared squared minus a squared b squared. We can rewrite this as the product of two binomials, a squared plus b squared minus ab, and a squared plus b squared plus ab. So our expression becomes the product of a minus b, a plus b, a squared plus ab plus b squared, a squared minus ab plus b squared, plus the product of a squared plus b squared minus ab, and a squared plus b squared plus ab. Now we're going to look for common factors to further simplify our expression. Notice that the product of a minus b and a plus b is a squared minus b squared. So we can rewrite the first part of our expression using this identity. This gives us a squared minus b squared times the product of a squared plus ab plus b squared and a squared minus ab plus b squared, plus the product of a squared plus b squared minus ab, and a squared plus b squared plus ab. We're getting closer to our final factorization. Let's rearrange our expression to find a common factor. We can rewrite this as the product of a squared plus b squared plus ab, and a squared plus b squared minus ab, multiplied by the expression a squared minus b squared plus 1. So our final answer is the product of a squared plus b squared plus ab, a squared plus b squared minus ab, and a squared minus b squared plus 1. We've successfully factored the original complex expression into a product of three simpler factors. Open parenthesis, a plus b plus c close parenthesis cubed, minus a cubed, minus b cubed, minus c cubed. Our goal is to factor this expression completely. This is a challenging problem, but we'll break it down into manageable steps. The first step is to rewrite our expression by grouping terms strategically. We'll use this rule to group our expression into two parts. This will help us apply the difference of cubes formula. We can rewrite our expression as open square bracket open parenthesis, a plus b plus c close parenthesis cubed minus a cubed close square bracket, minus open parenthesis b cubed plus c cubed close parenthesis. This grouping is strategic because we can now work with each part separately. Now we'll apply some algebraic formulas to simplify our expression. For the first part, we can view open parenthesis, a plus b plus c close parenthesis cubed minus a cubed as a difference of cubes in the form a cubed minus b cubed. We know that a cubed minus b cubed can be factored as open parenthesis, a minus b close parenthesis times open parenthesis, a squared plus a b plus b squared close parenthesis. In our case, a is open parenthesis, a plus b plus c close parenthesis, and b is just a. Applying this formula gives us open parenthesis b plus c close parenthesis times open square bracket open parenthesis, a plus b plus c close parenthesis squared plus a times open parenthesis, a plus b plus c close parenthesis plus a squared close square bracket, minus open parenthesis b plus c close parenthesis times open parenthesis b squared minus bc plus c squared close parenthesis. Notice that we factored out b plus c from both the first and second terms. Now we need to expand and simplify the expressions inside the brackets. We'll use these rules to expand. Open parenthesis, a plus b plus c close parenthesis squared equals a squared plus b squared plus c squared plus 2, ab plus 2, ac plus 2bc. And a times open parenthesis, a plus b plus c close parenthesis equals a squared plus ab plus ac. Let's start by expanding the first bracket. We have the expression equal to b plus c, multiplied by a squared plus b squared plus c squared plus 2, ab plus 2, ac plus 2bc plus a squared plus b, a plus ac plus a squared plus another term, which is b plus c, multiplied by negative b squared plus bc minus c squared. Our first step is to combine the terms inside the parentheses. Notice that we have a common factor of b plus c in both terms. We can distribute this common factor and combine all the terms inside the parentheses. Now, let's simplify by combining like terms inside the parentheses. First, let's count how many a squared terms we have. 1, 2, 3 a squared terms. Next, the b squared terms. b squared minus b squared equals 0. Similarly for c squared terms, c squared minus c squared equals 0. For the ab terms, we have 2ab plus ba, which is the same as 2ab plus ab, giving us 3ab. For the ac terms, we have 2ac plus ac, which gives us 3ac. And for the bc terms, we have 2bc plus bc, giving us 3bc. So after combining all like terms, our expression simplifies to b plus c, multiplied by 3a squared plus 3ab plus 3ac plus 3bc. Now, let's factor out the common factor 3 from the second set of parentheses. So we get 3 times b plus c times a squared plus ab plus ac plus bc. Now, let's group the terms inside the parentheses to see if we can factor further. Let's group the terms as follows, a squared plus ab and ac plus bc. We can rewrite this as a times, a plus b plus c times, a plus b. Now, we can factor out the common term, a plus b, from the expression inside the square brackets. So we get 3 times b plus c times a plus b times a plus c. And this is our final answer. Thank you for watching. Don't forget to like, subscribe, and hit the bell icon for more math lessons. NENOMATICA, where mathematics meets YouTube excellence.